Hi, everyone. So, my apologies in advance if you hear some very loud dog barking in the background. The kids in the neighborhood are about to leave for school, and my oldest dog doesn't want anything to do with that. So, this is a quick video about mole ratios POGIL Part 2. And this is where things get a little tricky in terms of stoichiometry. Because you're not given moles directly. And so we're going to have to kind of indirectly get to moles so that we can use our balanced equation and the mole ratios in that balanced equation to help us. So the question that is asked in mole ratios POGIL Part 2, and that is posed at the end of Part 1 actually, is what mass of nitrogen is needed to produce 30.0 grams of ammonia. Now, we've learned all along that mass in science is measured in grams, and so we have, the information that we have is that we have 30.0 grams of ammonia. And I realize I said half about 17 times there. Sorry about that. What we want to know is the grams of nitrogen, because we are asked about the mass of nitrogen. And we have the balanced equation here in the middle of the page here. And that shows that we have a mole ratio of 1 to 3 to 2. And actually, in this case, I think it's good to get in the habit of maybe circling the thing that we start with, which in this case is ammonia, and perhaps underlining the thing that we want to get, which in this case is nitrogen. And then if it helps you, and occasionally there will be multiple parts to a problem where it'll come back in, but in this case, we have nothing to do with hydrogen. We can just assume that we have hydrogen in excess. We have more than enough to work with. So I'm going to go ahead and cross that out just so it doesn't distract us. So if we just have moles here, if we were asked how many moles of nitrogen are needed to produce 30 moles of ammonia, that's a pretty easy calculation for us by now because we simply use the mole ratios. We'll talk about how that applies in a few minutes. But in this case, we don't have moles yet. And so if we don't have moles, step one is always to get moles. So in a lot of stoichiometry problems that we do, you may not need to do step one because you may be given the number of moles of a given substance. In this case, we have to get moles. And if we have the mass, we know how to get moles because we've taken the molar mass of that substance and we've divided by that molar mass to get the number of moles. So I'm going to go ahead and write that in here. We start with our 30.0 grams of ammonia. And I find it very helpful to write in the formula for the substance, just so I keep track of what I'm working with. And from several assignments that we've done so far, I know the check-in we had last week, as well as part 1 of this POGIL, we know that the molar mass of ammonia is 17.04 grams. That would be 14.01 for nitrogen plus 3 times 1.01 for hydrogen. Add them all up and you get 17.04. Then we have 1 mole on top and we get the number of moles. And I probably should have calculated this first, but if we do that very quickly, we get 1.76 moles of ammonia. So that's our first step. Now that we have moles, we can use the mole ratios, and that's the whole idea. If we can figure out the number of moles of something, we can always relate it to the other things in the equation. We can't do that with masses because different substances have different masses, but 1 mole of anything contains the same number of particles. So now that we have moles, we have something we can work with. So step 2 in this process is to get the mole ratio. And the mole ratio is always structured as I wrote here. What we want to get will be on the top, and what we have will be on the bottom, so we can pull it out. So I'm going to carry over that 1.76 moles of ammonia from the previous slide. And I'm going to use the mole ratio from the balanced equation to help us out. I'm going to go ahead and write that equation down here just to remind us. And again, hydrogen doesn't really matter here, but I'll write it in because it's part of the equation. I don't want it to feel left out. And so what we have is ammonia. And so we want to cancel out the moles of ammonia by putting 2 moles of ammonia. I can't believe I just wrote 1. Sorry about that. And that 2, again, comes from the balanced chemical equation. And on top, we're going to put what we want. And the question asks us about nitrogen. So we have 1 mole of nitrogen on top. So if we do the math, if we take 1.76 and we multiply by 1 and we divide by 2, we should get 0.88 moles of nitrogen. And that makes sense because we know that the ratio is always going to be 1 to 2 no matter what. So we should have exactly half as much nitrogen as we do ammonia. So everything's good so far. However, the question asked us, in this case, not to get the number of moles of nitrogen, but to get the mass of nitrogen. Mass is in grams, but we also know how to convert between moles and grams. So if we want to get the grams of nitrogen, all we need to do is figure out the molar mass. So I'm going to go ahead and carry down this 0.88 moles of nitrogen. And we're going to set up another easy one-stepper here. And the conversion factor here, we're going to cancel out moles by putting that on the bottom. And on top, if we want to go from moles to grams, the conversion factor is always the molar mass. In this case, 14.01 times 2 is 28.02 grams. And if we do that multiplication, 0.88 times 28.02, we get, I'm going to go ahead and round to 24.7 to get 3 sig figs, 24.7 grams of nitrogen. So, if we want to do this one step at a time, this is a great way to do it. However, if we want to put this all together, if we want to do one continuous dimensional analysis problem, that may be something that you connect with a little better. So I'm going to show you how that works as well. So if we're putting this all together, I don't know why I need to write this at the top, but I'm going to go ahead and do it. It's going to look good on the thumbnail on YouTube. So we're going to start with our 30.0 grams of ammonia. And the first step is going to be, and keep in mind, we're just multiplying by fractions here. So if you see this slightly differently elsewhere, then that's fine. So 30.0 grams of ammonia. First step is always to use the molar mass to get moles. And remember, when we're using the molar mass, the other part of the conversion factor is always just 1 mole. We don't use the equation yet. Now, once we have the moles of the substance that we want to start with, we do start with, we use the mole ratio to convert between the moles of one substance and the moles of another. So we had our 2 moles of ammonia in the equation and 1 mole of nitrogen, because the question asked us about nitrogen. Now, if we were asked to figure out the moles of nitrogen, then we'd be done at this point. We wouldn't need to do another step. But since the question asks us about the grams of nitrogen, we do need to do one more step. We need to take the molar mass, 28.02 grams on top, and 1 mole on the bottom, so we can cancel it out. And then, if we do all this math out, you'll notice that we get an answer equal to 24.7 grams of nitrogen. And because we didn't round here, the answer may be slightly different, but the method is exactly the same. All we did here is we took each one of those 3 individual steps and we combined them into one big problem. Whichever way we do it at this point is fine by me. As long as you can show your work and see the process, we're fine. So I hope that this is helpful for mole ratios POGIL number 2. It'll help you see kind of what people are doing well and what people aren't. And I hope that